So today we're going to briefly talk about how and why organic matter accumulates in putting greens and methods or ways that we can manage that accumulation of organic matter. And some of my slides are with Bermuda and others are with bent. I understand that most of you will be managing bent grass in your golf courses. What we see here is an increase of organic matter Okay, now I hear me, Xavier. Okay, we need to stop that. Okay, I can hear it behind me.
Okay, turn down the volume. So
of me?
Yeah.
Or that?
Of the interpreter, if you can.
Okay. I don't know how to do that.
Well, your own volume.
Okay. Hang on. Okay, but then, okay, there. Now, can you still hear me though? Okay.
Yeah. Is it fine?
Well, I can still, okay, there. Is that better? Should I continue?
Yes, please.
Okay.
If it's fine for you, you can.
Yep.
Okay.
Okay. But I can hear the translator behind me talking. Okay. There we are.
What you can do is you can if it's a problem for you, stop your audio channel in English. And
okay.
If it's any problem, I will tell you.
Okay, so if I stop my channel in English, though, okay, hang on, I'm going to do that.
Yes, on your right side there is.
Okay.
Okay, let's do that.
I did that. Hang on, now I got to get back to where I am. Ah, where'd it go? Okay, okay, hang on. There I am.
Okay.
Okay, there. Now, is everything working?
Okay.
And yes. She can still, okay. So, continuing on, sorry guys. So what we have here is something you all see, which is thatch. And sometimes you will see in research or presentations, they will separate it along this line into mat, which is less decomposed, and then the thatch, which is very decomposed. But regardless, you have this layer of organic material that's at the top of your green or your fairway. We have thatch as a problem when you have excessive thatch, and then we get scalping, and then we start to get where the water will not penetrate into the thatch and it will not wet the soil. So thatch can contribute to the development of dry spots or hydrophobic spots in the soil. One way that we often use in research to test the hydrophobicity of the soil and how thatch may affect that is we do this water drop penetration test. And what we do is we take a soil core and we let it dry completely. We bring it to the lab or to your office and we set it down and we let all the water go away. And then you take little droplets of water and you drop them down the length of your soil. And you can just get a relative idea of how quickly the water absorbs or goes into the soil. And you see here is a water droplet that has not yet penetrated or gone into the soil. So this soil is a little more hydrophobic at that point. And that helps us produce this kind of data. And what we have here is the time in seconds for the water to go into the soil profile. So again, the core is laying on its side, and here is the grass, and this is the length of the core to about 20 or 6 centimeters. You see here is a control soil to which we've not added any wetting agent. So this here is an experimental wetting agent. I think that this was actually the material that's now sold as Revolution, a wetting agent. But what you see is the addition of that wetting agent significantly reduced the time for the water to adsorb into the soil. We eliminated the dry spots. And you see that that works for a good 3 centimeter depth. So having thatch or organic matter can affect that. And this is a very easy test to look to see if you have the development of a hydrophobic soil. Now, as turfgrass managers, you all know the causes of thatch. Grasses that grow very strong or are vigorous, over applying nitrogen, adding too much water, and not mowing frequently enough, or at the wrong height. Now, for most of you as professionals, this is not a problem. I tend to see these kinds of problems with homeowners or in sports fields where the person who takes care of the pitch or the sports field is not a turf manager, but perhaps the coach. Here we have a Bermuda grass. This is a cultivar called Celebration. Notice here all of this. This is actually the poana, the annual bluegrass that is finally dying away in June. But here, this is one plot and this is another plot. The only difference between these two plots is nitrogen fertilizer. Here is a control that received no nitrogen fertilizer, and here is a plot that received too much nitrogen. So when we went and ran the vertical mower through here, we see how much extra organic matter was created. Bent grass and hybrid Bermuda grass, as we get new cultivars, often they have high shoot density. There's more organic matter produced. And on the Bermuda side, which again, not as many of you have Bermuda grass, but here we have one of our oldest, which has been around since 1960, and both of these grasses are from the 1990s. So Champion and Tiff Eagle are known to be able, they can be mowed at lower height. And you see in every month in which we measured the depth of the thatch, these are much more thatchy. They create more thatch than this older and more open cultivar. So it's a trade-off. You want a grass that can be mowed low at a low height with high shoot density, but sometimes they do make a lot of thatch. Now, a problem with turf grass that no one else has is that when we try to control this organic matter, we have to do so that it does not interrupt the play of the golf game and that it is not visible. You know, a farmer doesn't have that problem. They can just go and turn the soil over or manage the organic matter, and it doesn't matter what it looks like. But in turf, it has to look pretty as well. So we use things like vertical mowing, and we might aerify, and we will top dress. Vertical mowing is really your #1 tool for controlling thatch in your putting greens. Now, we have these strange things like for home lawns, but they're very hard to use, and you can imagine how long this must take. So our vertical mowers that we use in the golf industry tend to be separated by how severe or how much damage they will make to your green. So we have material or equipment that is standalone. That piece of equipment is a vertical mower, and it really doesn't do anything else. Or you may put vertical mowing reels on your triplex mower. And then the least severe are what we call groomers. And those are really intended to simply sort of comb or keep the grass under a high quality. They're not so much intended to remove thatch. So our most severe unit is some type of a standalone unit. One commercial trade name is the Graydon. There are certainly many other vertical mowers that are out there that are similar to a Graydon. So here's an example, and I know many of you have done this. You see you have significant organic matter being removed. That will have to be swept or taken off the plot. Often for bent grass here in the United States, we do our bent grass vertical mowing in the coolest part of the year as we go into fall. So for us, that would be September. This is actually vertical mowing on a Bermuda grass green, and you see we have gone one way, and then we go another way, and then we come back again. So we really open up this area, and then we'll top dress and encourage it to grow back. Now, one of the problems with that, of course, is that you damage the green, and it does take time to grow back. So one of the things we looked at was what we called a high maintenance program, where we were using that standalone vertical mower 4 months out of the year. This was for Bermuda grass and when the grass was actively growing. The problem, if you look at all the lines here, for the high maintenance, lots of vertical mowing, was that the grass could never recover. Here is the quality of the putting green. Right around 5 is a decent quality green, and you see the excessive vertical mowing did not help the grass to recover. It was too much. The standard method was that we verticut deeply about 2.5 centimeters, but only twice, here and here. And what you see is we got the thatch under control, and the green had time to recover and get high quality. And then we vertical mowed again, and again the green had time to recover. So originally, when some of these severe vertical mowers were introduced, people with these high shoot density greens said, oh, I have to use it a lot. And I think we're coming away from that because it simply takes too long for the grass to recover from this vertical mowing damage. So now we are vertical mowing either less often or not as severely when we do it frequently. Others have seen similar work. So here you have the percent organic material in a Bermuda grass putting green. And what you see when they take samples and burn them up in the oven, so this is how we measure organic matter content, that hollow tine aerification one time does not reduce organic matter compared to the control. You need to do that aerification twice or 3 times for best organic matter control. But vertical mowing 3 times a year significantly reduced organic matter as compared to the control. Our 2 best things are to take out that organic matter more frequently than once or twice. You need to do it about 3 times a year. Here we have bent grass, and we see the same kinds of results. So again, here is the depth of the thatch and the mat. So what this column is doing is, here's your surface, and it's measuring the actual depth in the green. The problem with that is that when you only measure depth, if you are in a heavy top dressing program, adding sand to the green, your thatch depth may actually go up because you have sand in there. But really, your organic matter is decreasing. So sometimes the best number is to look at the organic matter loss by, again, burning up that organic matter in an oven and getting a number. And you see how over 2 years in this bent grass green, vertical mowing reduced organic matter by 10%. So did core cultivation, but grooming increased it because you're stimulating shoot growth. The best combination are down here with core cultivation and vertical mowing. So groomers may not be that useful if you have a deep thatch problem. They're really used more to help eliminate grain or uneven golf ball roll across the green. We did some research looking at the spacing of the groomer. So here is the groomer at 6.4 millimeters. So between each groomer blade is 6.4 millimeters. Here is the groomer, and between each is 12.8. So this groomer is much wider between cutting blades than this one. Why do we care? Both bent grass and Bermuda grass have stolons and rhizomes. So if here is the soil surface for bent grass, there may be above ground stolons, which are stems, and from every node, here's a node, can come shoot growth. Here's another node. So if you come through with a groomer and you lightly cut, you will encourage shoot growth from that node. That's one reason we groom. So a groomer that has a narrow spacing, may do a better job of encouraging shoot growth from all these nodes. So what did we find? We found that grooming helped a little. So here, as we groomed, we had, you see again, as you groomed, you had some slight increases in thatch depth. So we were, again, sort of stimulating shoot growth. And here you see no groomer, and once we added the groomer, a little bit of increase in thatch. But a lot of times when we measured this, we did not see a lot of effects of grooming on thatch depth. What about shoot density? Yes, in some cases, as grooming frequency increased, so here and here, where I have the numbers in red, as we groomed more frequently, no grooming, once a week, 3 times a week, or 6 times a week, we increased shoot density. So grooming seems to increase shoot density and increase plant growth. It didn't really matter whether the groomer was 6.4 or 12.8 millimeters in spacing. Frequency of grooming was more important than spacing. We did not see any effects on golf ball roll. The stimp meter readings were unaffected by grooming. So what about some other work? Back to this bent grass putting green that Senora McCarthy has done. Again, adding grooming here shows the same thing we did. Grooming seems to stimulate plant growth and actually may increase your organic matter. So what about aerification? What we're going to do here is to insert a tine into the soil, either hollow or solid. Typically, we think about aerification to relieve or fix soil compaction. We don't tend to think about aerification for removing organic matter. But some of the research is showing that it does help with organic matter removal. Where aerification really helps is when you have really layered soils. And you see here an example of a subsoil with 1, 2, 3, 4, 5 different layers have been added to this soil. And what that can do is create problems with water penetration. So what do? We come in here and we aerify, take that soil away, and then top dress or leave open to try to create water movement. So we have many different types of aerification units. This is more of a standard unit that you might use on a green. And here we have a deep tine unit that we might use for a fairway or a sports pitch, or if you have a very compacted soil. And of course, the tines can move in and out. They can be solid or they can be hollow. And then we have the smallest type units that a homeowner might use, that it just rolls along the ground and you put weight in here and you just disturb the surface. And then the newest are the air injection systems, where these go to the ground and they have compressed air that injects. We have just started to do research with this unit. If you have very sandy soils, it seems to work well. The air effects last for about 7 to 10 days, and then the channel that you put this tine in, here's the soil, and the air comes out here. And what we have found is that we kind of make a channel of air, a hole here. After about 7 to 10 days, it sort of falls back in. It's excellent for drying wet spots, and it is slow. It takes a while to work across a green. So some other work that we have done with aerification tines, and then we measure the compaction. So we do that with penetrometers. So this has a loaded tip. You push it into the soil and you measure the compaction in the soil. So the harder it is to push into the ground, the higher the number. Here we're on an athletic field. Here we are on equestrian turf, where horses are jumped over that big fence. So for example, this is the data. Here, these blue dots are using this piece of equipment. So we went, and after 2 years, we had aerified with this 8 times. Here is our control, never aerified. You see how deep in the soil we get a very significant reduction in compaction. So again, compaction measured using that unit. It has very little effect at the surface on organic matter or thatch. This does a wonderful job of relieving soil compaction. When we only aerify in the surface, we also see this reduction in compaction. So these are hollow tines. We take away the soil and you see a very significant reduction. These are solid tines. So it's this unit, but we are not removing any soil. We are merely pushing a hole into the soil, as if you took a pencil and stuck it in the ground. And what you see is after 8 times over 2 years, we actually created a little zone of compaction. So what happens with that hollow tine going into the soil over and over, we have a little zone of compaction right here. So you have to be careful with these solid tines. They're excellent for moving quickly, helping to dry, and temporary relief. But the hollow tines, when you remove a core of soil, are better for relieving compaction, and they also do remove organic matter. Now, what about root dry weight and shoot density? Everything helped to grow roots. No matter what piece of equipment was used, we saw improvements in rooting. But in terms of thatch, for our research study, aerifying had no impact on thatch depth. Okay? Now, this is just measuring the depth of thatch. So aerifying with hollow tines with this piece of equipment once, twice, or 4 times a year did not affect the depth. But again, remember, I said that number sometimes can be a problem because it's depth, which includes top dressing. Really, we should have measured organic matter content, because see here, top dressing again is increasing our thatch depth. So what about top dressing? Usually we are talking about a thin layer of sand that is applied to our bent grass or our Bermuda grass. It helps to smooth it. The sand works down into the thatch layer and helps it degrade. It helps your turf heal from divots, and it's excellent to help fill the grooves after vertical mowing. Very good for that. In the United States, especially in lower cost or places with not much money, top dressing is terribly underutilized. This is an American football field that really needs to be aerified and top dressed. Organic matter accumulation is not a problem here. But again, if we just measure thatch depth, your numbers can look weird or not quite right because you have the accumulation of sand. So in research, again, we will burn these samples up in the oven to measure organic matter content, not just depth. And here's an example. You see all the layers of sand in here that make this bent grass green look very thatchy, but there's a lot of sand in there. And again, to show how the inclusion of top dressing can create a number that's a little artificial. Here, when we top dressed frequently at high rates, we see the increase in thatch depth because of the accumulation of sand. So now I think we have a lot more people that are aerifying more frequently, lo siento, that are top dressing more frequently at lower rates. We see the same thing in Bermuda grass. In bent grass. So here is the same thing in bent grass. So you see, if you just measure the depth, here is a spring core aerification and a spring and summer. Far more thatch depth, the number is larger than compared to the control. But when you actually measure the organic matter content, you see how both spring only and spring and summer aerification significantly reduce the organic matter as compared to not aerifying. And this is in a bent grass green. So we do want to top dress, and probably lighter and more frequently. Now, the last thing that I want to mention are some of these new materials that are biological dethatchers. They often contain organisms such as bacillus or pseudomonas. Sometimes they may contain some iron or a little bit of nitrogen. So these materials are sprayed onto the soil, and the idea is that these biological materials are stimulating the breakdown of thatch and organic matter. There are quite a lot of them on the market, and you see these sort of materials like this. This material has some type of a bacillus in it, and notice it's coming from an all organic product. So there's sea kelp and fish meal and alfalfa meal in this as well. So we did a fair amount of work with these in bent grass. We had 2 different old bent grass cultivars. We either vertical mowed or we did not. We top dressed or we did not. And then we had the bio thatch or we did not. So this bio thatch contained 2 different forms of bacillus. If the numbers are in red, they are significant. We actually measured this 24 times over 2 years. And you see that when we vertical mow, we often reduce thatch. The bio thatch, however, also reduced thatch. We had, out of 24 measurements, there were about 6 times when the bio thatch was helping to reduce thatch depth. So it is not as effective as vertical mowing, but there is some evidence that these products are working. Others have seen similar things, and here we have the putting green work of Dr. McCarty, and here is his biological control product, the same product with which I worked, and you see a 13% reduction in organic matter as compared to the control. So the easy things to help stop the accumulation of thatch: don't overwater, don't over-fertilize, and mow correctly. Your first tool is probably vertical mowing to keep thatch under control. Core aeration also seems to help, but you have to do it more than once, and you need to use hollow tines to remove that material. We are starting to see some benefits with these biological materials, particularly the ones that contain bacillus. There are other experimental products, and we're not sure yet how they work. Our work with vertical mowing has shown that to get recovery after vertical mowing, you do need to look at soluble sources of nitrogen and top dressing. So vertical mowing and then applying slow release nitrogen is not as effective. And then layering is also an issue. So if you inherit someone else's golf course to take care of, and maybe they have laid a lot of sod, that can be a problem. So that is what I have for the day, and I have 5 minutes for questions if perhaps you have some. Thank you.
Hi, hi, Beth. Thank you very, very much. An excellent presentation, as always. There is one question.
Okay.
You have been talking about removing the organic matter in the topsoil, but considering the relationship between organic matter and the microbial population in the topsoil,
yes.
What do you think about it? Which would be the minimum level of organic matter to keep the microbial population healthy?
So I think that's a very important point. Your microbial population will be doing fine within the typical levels of thatch and organic matter that you manage. Research is showing that populations can recover very nicely after really aggressive things like using methyl bromide. We did work with methyl bromide fumigation, and really within 2 weeks we had recovered levels of a lot of the microbes that are of interest to us. So in a proper fertilization scheme that you all use, you've got a nice pool built, especially since your superintendents are so limited on herbicides and pesticides and fungicides. You tend to manage for a very healthy microbial pool.
Okay, thank you. Great. Another question. You're talking about light top dressing,
Right.
which would be which rates are you talking about? That's the point.
That's so hard because I always try to get to something like cubic meters per square meter,
Yes.
and people are like, no, and so they just say, I lightly dust it. I do like 0.125 millimeter, and it's really hard to come up with that number, and I need help myself on that.
Okay. So no, it's almost. I don't know if you have more time or you need to
I've
go to.
got 5 minutes.
You have 5 minutes. Okay, let me check if there is any question for you. Okay, so that's all.
Okay. Well, thanks,
Okay.
guys. All right.
So thank you very much again for your
All right.
commitment with this project.
I hope the translation worked. The system seems to work well on my end.
Yes, I think so. I've been listening to both of you, to you and to the interpreter.
Okay.
So I was getting crazy.
Yeah, that's hard.
And no, it worked very well.
Terrific. Well,
So
thanks, guys.
thank you very much,
All right, bye now.
and see you soon. Bye
See you.
bye.
Bye.
Bye. Bueno, pues nada, como os he comentado antes, Beth tiene clase, pues nada, hemos hecho una pequeña presentación, un poquito más corta de lo habitual. Solo recordaros que, bueno, el próximo webinar, que será el 27 de abril, pues lo presentará el doctor Jim Brosnan de la Universidad de Tennessee y hablará sobre, indicadores de malas hierbas. Bueno, no indicadores, o sea, poquito nos hablará de qué tenemos que considerar, en qué punto, o sea, qué nos cuenta el césped en el punto en que puede favorecer la aparición de malas hierbas. Ya considerando también, bueno, esto ya está no acaso, las pocas herramientas en fitosanitarios que tenemos. Bueno, y por mi parte, pues nada más, como siempre, pues agradecer a la colaboración con la Asociación Española de Greenkeepers, que estamos trabajando conjuntamente para ofreceros a todos vosotros estas pequeñas píldoras de formación. y a los patrocinadores como Compo, Expert, Syngenta, Semillas Fito, John Deere, Jacobsen, Hunter y Wiedemann, pues que gracias a ellos podemos trabajar para vosotros. Pues nada, por mi parte nada más y nos vemos el 27. Hasta pronto, adiós.